from now on. So in this case here, we've been asked to solve x squared minus 14x plus 3 by completing the square first. And then after that, round your answers to 1 decimal. So whenever you see this question, round your answers to 1 decimal. You think you're gonna need your calculator, and because you need to round a number, so it's gonna be in the form of a sort that you need to do the calculation on. Okay, so usually that's what happens. So the first thing is we need to complete the square. Whenever I'm asked to complete the square, the number I'm drawn into is this number there. Yeah, negative 14. I know I need to halve that number. So it's going to be x minus 7 square. So I've got my a, and I've got my plus 3. But because I'm going to add 7 square, which is your 49, I need to take away 49. So that's how basically you can quickly do it. So half that number, put it there, the square, plus 3. Because we add 7 square, we need to compensate minus 49. That's the first line. After that, you tidy up. You've got 3 minus 49, which is negative 46. Okay, so have a look. They've asked us to solve this equation when it's equal to 0. What if I try to get rid of the negative 46 here? When you solve an equation, yeah, so you need to do the opposite. Yeah, to move. So people will tell you move it to the other side, or if you've got taken away 46, what's the opposite of taken away?
Add.
Add. So basically, to keep the balance for this equation, you add 46 on each side. So basically, you would just do plus 46 on this side. That would get rid of that 46, but because we've done that, we need to add plus 46 on this side. So that's the first step of solving this equation, and that's why it becomes 46 on the other side when you move it onto the other side. Now I've got x minus 7 square equal 46. Can I get rid of that square? What's the opposite of squaring? So if you got this square, to get rid of that square, you just take that, you just put that on. So what's this? Yeah. So if I take the square root of 5 square, what do I get? 5. Because 5 squared is 25. That's how you get rid of a square. Just think about 25 being 5 square, square root of 5 square, that's 5. So we need to take the square root of 46, and square root of x minus 7 square is just x minus 7. So you end up with x minus 7 equal root 46. But because, remember, a positive time a positive gives me a positive, and a negative time a negative gives me a positive, you need to give the answer, both answers, the positive and the negative answer. So that's the working here, is x minus 7 equal plus and minus root 46. Okay? And now...
Why is that plus minus root 46?
Yeah, because if I do, let's say I had, for the sake of it, if I tell you x squared, I'm just giving you an example, equals 16. When you solve an equation and you've got this square, you expect 2 answers. Okay?
Right.
Because if the answer is x equal root 16, what is root 16?
4.
4. But what is negative 4 times negative 4?
Negative
16.
Plus 16. So
Plus
you've
16.
noticed you've noticed that 4 and -4 are both good answers. So
Right.
you've got 2 solutions. And
Right,
that's
okay.
because of that, the +4 and the -4, which is a plus and a minus root 16, forces you to get the 2 answers.
Right, okay.
And the trick is, whenever you're going to solve an equation that has got an x squared in it, you're expected to find 2 answers.
2. Okay.
Okay? And here, to get the 2 answers, you take a positive and a negative value of what we would have done if we had x squared equals 16.
So see if you'd forgotten to write in that plus negative sign.
So if this was a a 2 marks, you only get one marks, for example.
Okay.
If you get an x squared equals 16 and then you write x equal +4, and you would notice sometime if you get something as a 2 marks, think about it, you probably need 2 answers. It'd be too easy to say, oh, that's just 4. Okay. Now that
mean plus or negative answers.
Yeah, so I've got 2 answers, a positive and a negative answer. But here, remember, I've got x minus 7. They've asked me to find x though. So I've got to take away 7. What's the opposite of taking away 7?
Adding 7.
So to get rid of that, to take away 7 now, you need to add 7 on each side.
Mm-hmm.
And my final answer is going to be x equals 7 plus root 46, or x equals 7 minus root 46. These are my 2 answers. And this is when you're going to get your calculator, because look, they've asked us to round an answer to 1 decimal. If they had asked us to just give the answer as a third form, let's say it'd be a non-calculator question, for example, you would leave it like that, 7 plus root 46. But because they've asked us to round the answer to 1 decimal, you need to do 7 plus root 46, SD 13.78, 23, and the other one is 7 minus root 46, which is 0.21767. And then to round to 1 decimal, you look at the second decimal, yeah?
Mm-hmm.
If it's 5 or higher, you round up. The 13.7 will become 13.8. If it's less than 5, you just keep the number there, the 0.2. It's a bit like you've rounded down to the closest.
Okay.
And these are your 2 answers, 13.8 or x equals 0.2 to 1 decimal place. And that'd be quite a few marks actually, because you've got 2 marks to complete the square, and then another 2 marks to do the work here. So this question would be probably at least 5 marks, 5 or 6 marks.
Quite a lot.
But the difficulty here is to remember the plus and minus here.
Yeah.
Okay. And be able to as well round to 1 decimal, but they expect you to know how to round at this level, okay? So let's see if we've got another example. This time, look, they've asked us leave your answers in third form, so that'd be a non-calculator question. So I'm going to pause. I'm going to let you work on completing the square first. And then we'll start recording again. I'm going to resume recording. Yeah, so basically, while we wait, we can just go through a couple of questions. So maybe what you could do is try the third one, because that's more like what we've been doing so far. So if you're asked to factorize 24y minus 16y squared, so
It's common factor.
Common factor, yeah. First thing first, we try to find common factors. numbers first. So I've got 24 and 16. I can see that 4 and 2 make 6, 6 and 1. So I'm going to try 2 first, but because I divide 24, I get 12. I can do 2 again. 16, 8, and another even, so 4.
4.
Yeah.
4y. Yeah, 6, 4y.
But have a look. Have a look. I did 24. Divide by 2, I got 12. Divide by 2 again, I got 6. Yeah? So that means I can go 8 for 24. 16 divide by 2, get 8. Divide by 2, 4. And I could do divide by 2 again. So I can do divide by 2, divide by 2, divide by 2. So that means I can divide by 8. 2 times 2 times 2 is 8.
So you could go 8 into 4 into, no, 4.
Yeah, so 8. So you would put 8 outside.
I went with 6. I could go further, couldn't I?
So to go with 6, you need to make sure that 16 is a multiple of 3. Because 16 is not a multiple of 3, then 6 wouldn't work. But we said we can go divide by 2, divide by 2, divide by 2. That means we can use 8. I'm going to get 8 outside. And I've got a y and a y square. I'm going to use y. So 8y.
6. No,
So, 24 divide by 2, divide by 2, divide by 2.
3.
3. And then for 16, it's just 2.
3 minus 2y.
Y. So you can give it like that, or you could have tried 2, and then you'll find out, oh, I can do 2 again, 2 times 2, and then I can do 2 again, 2 times 2 times 2. Okay, so it's up to you. It might take you longer, but you can have a look at the numbers and play with them. Okay, so that's how we factorize. The next one, I've been asked to find 2q squared times z plus r squared. If z equals 4, q equals 3, and r equals 2, and this is what we call substitution. So you've been asked to find a value when you've been given a value for each letters there that you are using. So that means substitute z with 4, substitute q with 3, and substitute r with a 2. So that is technically 2 times 3 square.
9.
So 2 times 9 times 4. Plus 2 square.
2 square.
So the easiest way to do this is 4 times 2 is 8. 8 times 9?
72.
72, yeah. So you would write 72 for that. Plus 4.
76.
And your final answer is 76. So that's how you would get your mark for this one. So it's called substituting. National 4, actually. Okay, so 5 3/4 plus 2 8, they've asked us, is that equal to 7 and 8? So we're going to deal with that and see if it's equal to 7 and an 8. So we've got what we call a mixed fractions and a couple of mixed fractions. The easiest way to do this is to deal with the whole numbers. So we've got 5 plus 2
7.
plus 3/4 plus 1/8. So that's the easiest way to add mixed fractions, guys. If you're asked to check this or evaluate, find a value for this, that's the easiest way to do it. So I've got 2 fractions. The only way we can add them up if they got the same denominator. 8 and 4. Can I make my 4 becoming an 8? By timing it by what? I get 8 by 2. But remember, we need to do the top as well by 2. Okay? So then that becomes 6 over 8. So I've got 7 plus 6 over 8 plus 1 over 8. So I'm going to write you the work in here. So 6 over 8 plus 1 over 8. And that is 7 over 8.
That's not the smile. That's not the smile and the kiss method. No, that's
No.
when you're multiplying dividing.
Because you could have tried 8 times 3, which is
Yeah.
24, plus 5, 29, divided by 32. But what you need to find is just the highest common denominator, because you've got here 8 and 4, and you know that 4 is just
Twice.
8 is just double 4.
Mm-hmm.
You might as well just double the top, double the bottom, and you've got the same denominator. Try and work with smaller numbers, because then it becomes easier. 7 over 8 is much easier to manipulate. So 7 plus 7 over 8 is just 7 7/8. And is that what they gave us to start with? No. So that's false. Yeah. So you would just say this is false because it's not 7 and 1/8. It's 7 and 7/8.
Yeah.
Okay. So that's how we add mixed fractions. You add the whole numbers and then you add the fractions.
Then when you're dividing fractions, you flip them, don't you? Is that
Yeah.
correct?
So if you divide two fractions, you flip the second one and then you change the divide sign as a multiply.
Yeah.
So multiplying or dividing are the easiest operations to use when you do fractions. Because when you add, you could see you need to find the common factor here, or the lowest common multiple between the two. And 8 is the lowest common multiple here. Okay?
Okay. Thank you.
Let me check that I'm still recording. So today we're going to look at what they call algebraic fractions, where you've got algebra like a letter and a number rather than just the numbers when you manipulate fractions. So you might think, oh, fractions with numbers already hard. What's going to happen if we add letters? So let's have a look. What's going to happen? If you can manipulate the numbers on their own, then you should be okay to do the same with when it comes to algebraic fractions expressions. Okay. So thing we need to find is highest common factor, because we're going to add or subtract fractions by making sure we've got the same denominator, the same way we've been doing the starter question. Okay. Once we can recall that term, the highest common, we're going to simplify those fractions by identifying that highest common factor. Yeah. So how do we create equivalent fractions? So if I tell you I've got 1 over 2, and I ask you to make an equivalent fraction for this, basically you keep.
Is that like making a 2 over 4?
Yeah,
so
it's
like
the same thing. So
thing.
because you've timed the top by 2 and the bottom by 2, yeah, you can say that's 2 over 4. So if you can remember that, or it's 50%, the same thing, 50 over 100. You time the top by 50 and the bottom by 50, you get 50 over 100.
Mm-hmm.
So that's what they mean by equivalent fractions.
For fractions, it just mean the same thing.
Yeah, the ratio, you should keep that ratio. The 1 over 2, to keep the ratio, you time, or you can divide. So I can take 50 divided by 2, that'd be 25, and 100 divided by 2, that'd be 50. So 25 over 50 is again an equivalent fraction.
Yeah.
Whatever you do to the numerator, you need to do the same to the denominator. Okay. So numerical fractions, there's an example. I've got half. Oh, taken the same example. Oh, there you go, 3 over 6. So basically 3 times 1, 3 times 2, that's 3 over 6. Now, if you got an algebraic fraction, 1 over x, to create an equivalent fraction, we can just multiply top and bottom by 2. 2 times 1 is 2. 2 times x is just 2x.
Yeah.
Or we can time it by 3 if we want to, or time it by a letter as well. So if you time your 1 by y and your bottom by y as well, so you get y over xy. So all these are equivalent fractions. Yeah?
Mm-hmm.
Let me tidy that up because it's used at the bottom anyway. Okay. So far, 5 over 7, you time by 2, time by 2, 10 over 14, time by 10, time by 10, 50 over 70. So equivalent fractions. Now, if I've got an expression like an equation x plus 1 as my denominator, same thing. If I time both top and bottom by 2, I've got equivalent fractions. If I time it by f, which is a letter, then you get again an equivalent fractions. Okay, so far, nothing too complicated with the fraction. Now we need to find out common denominators. So when we had numerical fractions, like 1 over 2, and we wanted to add to it, let's say 1 over 3, this is where you did the cross and smile, or kiss and smile. So 3 times 1, 2 times 1, and then you had the 3 times 2. The common denominator here was 6. Whereas when now I've got an x and an y, I just do 2 times 3, x times y, which is xy. That's going to be my common denominator.
Okay.
So if I had to add or take away, you would do y plus x. Okay. So this is how you find your common denominator. If I've got 5 over 7, 1 over 2, again, you would do 2 times 7 for this one, which is your 14.
14.
And if I've got a 3 over x plus 1 and 6 over 2y, you just do 2y times x plus 1. The same way, that'd be your common denominator. Okay? So I think my animation came a bit too late. I can fix that. So we can sometimes reduce fractions to a simpler form if the numerator and the denominator have a number or letter in common. Yeah, so let's take an example. If I've got 12 over 15, I can simplify the fraction by just saying, okay, it's the same as 4 over 5 because it's 3 times 4 and 3 times 5. So that's how you simplify a fraction.
Yep.
If the number at the top is the same as the bottom, as long as you've got multiplications or divisions, which is a similar operation, but you can simplify them that way. So now when it comes to algebra, we've got something similar. If I've got y squared at the top and y at the bottom, y squared is just y times y. Yeah? So we can simplify the y and the y, which technically is a 1, but it just becomes y. Remember we did that with indices, y squared.
Yeah.
Y 2 minus 1, which was just the 1. So you could have got the answer this way. Yeah? 2 minus 1 is just 1. Y to the power 1 is just y. Okay. So far, not too complicated. So we've got examples. How do you simplify 2b divided by 6b squared? Again, it's the same as when you were factorizing, we look at the numbers first. So can I simplify 2 and 6?
Yeah, 1 over 3.
Yeah, so it's 1 over 3. And b over b square, this time we need to watch because the b square is at the bottom. It's the same as b times b. So we can just simplify b and b. So the answer would be 2 times b, 6 times bb. 2 over 6 is a third. B 1 over 3b. So I'll let you try the next.
Is this touching on indices? This is it in some way? No, no.
Yeah, in a way, you could do it that way, or you can just write as a times a divided by a times a, and just start crossing the way they've been doing it up, you know, in the example above.
Yeah. A over a, which means just a.
Okay, so a times a divided by a times a. So if you can't remember indices, for example, you know, that is a3 minus 2, which is, you can just expand that a times a, and just start to simplify. So cross,
It's just one.
cross, cross, and you just end up with a over 1, which is just a.
I actually thought it was a to the power of 1, but no, like because it was.
Yeah, a to the power of 1 is a.
It's still a. Yes.
Yeah, it's a to the power of 0, which is 1.
A to the power of 0, 1. Sorry. Yeah, I knew that. I was just checking.
Yeah, so a to the power of 1 is just means a.
So it's just a.
So you can get it that way, or you can do it by going like that. Okay. So next one, 4pq divided by 12q. How would you simplify that?
1 over 3, but have it as 1p over 3.
How did you get that so fast? 4 over 2.
Because 4 goes into 12,
4 goes into 12,
and then q equals itself out. So you've got 1p left at the top, and then.
So you just did 4 out of 12, 3.
And then the q's equal themselves out.
Q cancel each other, so it was just 3p.
Yeah, 1 over 3, p over 3.
So
is that what you got? P over 3. Yeah. So 4pq divided by 12q, 4 and 12 is 1 over 3, yeah?
Yeah.
And then we've got a q
Right, yeah,
and a q cancel each other. Then you end up with just p over 3. I think you had said, is that what you said, yeah? P over 3?
Yes.
Yeah, that's it. That's how you simplify it. Divide by 4, and the q just cancel each other.
Yeah.
Let's try another one.
Six. E squared.
So it's 6e over 2f. No.
I got 6ef.
So let's have a look. 12 divided by 2, that's 6 at the
yeah,
top.
just put the zeros.
Yeah. So once you've got both, you divide by 2. So the bottom, the one at the bottom, because you've done 2 divided by 2, it becomes a 1.
Yeah.
And 12 divided by 2 becomes a 6. Now you've got e times e divided by e, that's just e. But usually what you'll see is they would just cross the e at the bottom and then cross the 2. So you keep the e, 6e, whereas f square over f cube becomes the 2, and this one becomes a 1. And your final answer is just 6e over f. And that's how you would simplify it.
I tried to be really smart there and I got it badly wrong, but I was close.
So yeah, e square over e, it's just e times e over e. So you could break it down the long root. But once you're going to play with indices, and the f square f cube is f2 minus 3, which is f minus 1. So that f here, because it's at the bottom, if you put it at the top, it becomes f to the power negative 1. Okay?
Yep.
So other examples, if I've got y minus 1 square and y minus 1 cube, I can just say that y minus 1 square is y minus 1 times y minus 1. And y minus 1 cube is the same, but y minus 1 times y minus 1 times y minus 1. And it tells you there, we can only simplify if the fraction is a product. So here you've got a product of factors. If I had a plus in between the two, you couldn't simplify. But because we've got a product at the top and a product at the bottom, then you can start simplifying by saying, I'm going to get rid of that y minus 1, which become a 1, and the y minus 1 here. Okay. Now, can I simplify further? Yeah, I've got another y minus 1 there and a y minus 1 at the bottom. So 1 times 1 is just 1 over y minus 1. Yeah? So that's how you simplify them. Or if you wanted to use your indices again, it's be y minus 1, 2 minus 3, which is y minus 1 to the power negative 1. And that's just 1 over y minus 1. In the second case here, it's even easier because you can simplify m minus 2 and m minus 2.
Just m plus 3.
And that becomes just m plus 3. There you go, m plus 3. Oops. So that's how you would simplify it. Okay?
Yep.
So let's try these. They look a bit more complicated, but they're very much the same, unless that what you've got is 1 plus 5g times 1 plus 5g times plus 1. And then you've got 1 minus 5g. So I'm going to let you try these two and see how you would come.
It's a lot of writing out.
Okay, so let's have a look. You can either use indices like you've done in the past, or you start crossing the 3 because you had it 3 times, and then at the bottom you had it twice. So that's a quick way of doing it. And the same for the 1 minus 5g. You cross that out, but then because it's 1 minus 5g times 1 minus 5g, you end up with just 1 plus 5g over 1 minus 5g. How was this one? Okay?
Yeah.
Yeah, it was.
2
I've
4.
got a bit of trick. I'm maybe making it more complicated. I've got to start using indices again. I do, because I'm just.
Yeah, you could do, for example, in this one, you do 3 minus 2, that's the one.
Yeah. So
And
that's
this
just
one
1 plus 5g.
would be, yeah, a 1 minus 2, which is minus 1, but if you put it at the bottom, it's 1 minus 5g. So try the next one there.
Yeah. Okay. This is 1 minus f take away 2. Not 1 minus f take away.
I got it 3 over 4
Did you do
equals
6
1
5
plus f over.
Did you deal the whole numbers?
Yeah, that were the whole numbers.
I knew that with 2, so that's 3 and 3 over 4.
I've done 3 over 4 and then bracket
Good.
1 plus f over 1 negative f. I don't know if that's right.
The 1 plus f at the top that hasn't got a power or anything, or got nothing next to it. Did you just do that as a? You cancel that out. Then that's 2.
So basically,
2 take away the 1
Just what position to put them in? The
Yeah.
plus and negative.
So the first thing you deal with is the 6 over 8. They both go into the 2 timetable, so you divide both by 2. So that gives you 3 over 4. So if you get that, that's the start. Then you've got a 1 plus f and a 1 plus f times 1 plus f. So the 1 plus f at the top will go with 1 at the bottom. So you end up with just 1 plus f at the bottom.
That's
yeah.
it.
So
yeah, I've done it wrong way around.
If you think by going through indices you get more chance to make an error, I would argue that it's probably safer to just write 1 plus f on the side. You just write what you've got. Okay, 1 plus f times 1 minus f. So that's the top. Time 1 minus f, right? So that's exactly what we've got at the top. And you do exactly the same at the bottom.
I can see that. It's just the I'm trying to maybe be a bit smart and trying to make life a wee bit easier for myself in terms of just saving me writing it. But that's I see where you're coming from in terms of just get it written out and then start eliminating. Just
I think at the start it's probably safer to just write them all, and now starting cancelling 1 to 1 rather than manipulating the indices.
Yeah.
Because here, when I've got all this, I'm just going to cancel out things. So 1 plus f goes with a 1 plus f at the bottom.
Yeah.
1 minus f goes with a 1 minus f at the bottom.
Yeah, so we've got them.
And I end up with 1 minus f divided by 1 plus f with my 3
4
and my over 4 here. So it's much, you've got less chance to make a mistake, put it that way, if you do it this way. What they're doing is, like you said, they're trying to make a shortcut by saying, okay, I'm going to replace the 2 with a, replacing it with a 1, you still end up with the same answer.
Yeah.
Okay. But as you practice it, maybe it's safer to just expand it completely.
Okay.
Okay, so I'm gonna let you have a go at these. I'll give you, 3 minutes. We'll go through the top 3, and then another 3 will go through the bottom 3.
W. Did you get 3W, Kirsty? Please tell me.
Oh yeah, sorry. I thought you were talking to yourself. That's what I got.
Even if you actually got it, and then just to confirm if I got it right.
Yeah.
I don't know. I'm just maybe doubting myself.
Next one, I got 8y squared.
Yeah, because you eliminated the. You can eliminate the y twice with that y squared left over. See the third one. Did you get 2 back 2?
Bracket F.
2 to the power. Minus 2 to the power of -3. No, that's wrong.
Oh. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
-2f to the power of 3. 2 brackets f is 2 to the power of 3.
Okay, so let's try the first one. So if you were to write everything on the first one, you would do 6 divided by 2 first. That is your 3, yeah? So 6 divided by 2 will give us the 3. And then W times W over W is just 3W. Yeah? Let me check that.
Yeah.
The next one, I need to divide the 4 by 4 and the 32 by 4. So then that gives you 1 over 8. Did you get that? 1 over 8, not 8. Sometimes the common mistake people would put.
Yeah, I've just put 8y.
Yeah.
Squared.
So that's a common mistake. 6 over 2 is 3. But 4 over 32 is 1 over 8.
Okay.
Okay. And then I've got y times y times y.
Y squared.
Y squared.
Which is the y square, because you get rid of. So it's 1 over 8 y square.
Okay. 1 over 8.
Yeah, common mistake. People put the 8 at the top because they go 4 over 32 is just the same as 32 over 4, but it's not. And on the last one, 1 over 2 stays 1 over 2. But I've got f minus 2 to the power 6 and f minus 2 to the power 3. Basically, you get it 6 times at the bottom and 3 times at the top. You cross the 3 at the top, and that means you're going to cross 3 at the bottom, and you end up with just 3 at the bottom, which is 1, 2, f minus 2 cube. Yeah?
Yeah. Yeah.
On the next one, this is the bit that plenty people would make a mistake. Remember what they say at the start? You can only simplify if they're all factors of each other. Factors mean multiply. If I had w time x plus 1, then I can start simplifying. But once you put a plus here, that's you can't simplify that. That just stays exactly the same, yeah? You can't simplify this. If this was a time, we could, but because it's a plus, you can't simplify. A plus or a minus, you wouldn't be able to simplify it. You just leave it the way it is. Okay, so this is the important bit. Every time we've been managed to simplify in here, we've had 6 times w squared, 4 times y. Here it's a 1 times f minus 2. This one, they've given you a hint. What do we need to do first? Factorize first. So if you got ay plus a, you factor, what's the common factor there? A, open bracket, y plus 1. Do you agree? Because
Yes.
it's a, so that's the first thing we need to do. We've got a multiplication divided by a y cubed. So that means I can simplify my a's, and we end up with just y plus 1 divided by y cubed. Let's check it. Yeah? Are we happy with that?
Yeah.
Yeah, so the difficulty here is to remember that you need to factorize. And law of the fractions, you will have factorizing. Factorization, finding the highest common factor. Or for this factor here, how can I factorize x squared minus 1? Yeah, difference of 2 squares, yeah? You've noticed them?
Yeah, x minus 1, x plus 1.
X minus 1 times x plus 1.
Sorry, Adrian, can I go to the second example there? Sorry, apologies. It's the y plus 1. Is it again just at the side there? How did you do the eliminating process? How did you cut that down again? I wasn't 100% sure.
So a times y, that's your ay, yeah? And a times 1, that's your a times 1. Now I've got a at the top and a at the bottom, the same way we've been doing, yeah. Same way we've been doing w.
The y.
Yeah.
Yeah, the y. I see it now. Sorry, you got rid of these and then just had y plus 1 at the top.
Yeah,
y cubed. That's fine.
Because it's y plus 1, I can't simplify with the y cubed because it's two different. Yeah, the two different entities.
That's fine. No, sorry.
That's fine. And for difference of 2 square, we said we've got x minus 1 times x plus 1. Then that means the x minus 1 can be simplified.
Is the answer just x?
Let's have a look. What is the answer? So write that down. X minus 1 times x plus 1.
Oh, plus.
Divided by x minus 1. So what are the two that we can simplify? X minus 1 there and x minus 1 there. And what do I end up with?
X plus 1.
X plus 1 on its own. Okay.
See, if you write that x plus 1, I presume you don't need to put brackets on.
You don't have to. You don't have to, yeah. Once you give the answer like that, you don't have to put the brackets. The same here, the y plus 1, they've removed the bracket. As long as you've got that divide sign long enough to know that it's for both. Because if that divide sign was short, then that means it's y over y cubed plus 1 on its own. Whereas no, it's y plus 1 divided by y cubed. Okay? And I think what we'll do is we'll do a couple of examples. Question 1. Couple of examples here, and then I'll probably let you go because it's been a long.
Sorry, Adrian, could you go back to that homework? Sorry, because I just write it down and then it's all colour coded.
Yep. So it's 6A, question 1.
Coordinated.
6A. Going through all the slides.
Is that what you like? You are quite. You choose like the.
Yeah, everything's colour coded.
People like that need.
With a highlighter.
Yeah. My homework, my examples, my rules, my good to goes.
Yep. It's all like things aren't glued in right, or I don't get allowed to do the writing, like looking for writing jotters in. She lets me do maths because that's just a ticking exercise, but I don't get to do writing.
Okay, so let's do a couple of these. I'm gonna pick, we'll pick a hard one and a kind of easy-ish one. That means you've got 1, 2, 3, 4, 5, 6 to do. So the first one, or they've even given us a wee hint here. Remember to factorize before we can simplify. So if we have to factorize, we will factorize. So b over 3b, I can simplify both the b's. But remember, just because we've taken it away, it doesn't mean it's a 0. B divided by b just means it's a 1.
1.
Yeah, and the answer is just 1 over 3.
Made that mistake once, so we'll make it again.
Yeah, some people sometimes, because they simplify, they think, oh, it's gone, there's nothing. Nothing for them means 0.
Yeah.
But remember, what we've done here is we've done b divided by b, which is 1. Okay, which is completely different than writing a 0. Or what you could, sorry?
What page was that in the Lecky? Sorry.
Page 48.
48,
that's 48.
Sorry, just interrupted you. Sorry.
For this one, I've got a 9.
Yep, so it'd be 3 over 4.
Yeah, a B, and another B. And at the bottom, I've got 12 A and a B. So 9 over 12, they both goes into the 3 time table.
3 and
so that 3 over 4. The A and the A cancel each other. That's a 1. And one B and another B cancel each other. That's a 1. And my final answer is 3B over 4.
Is that your highlighters going, Kirsty? Just like changing from one highlighter to the next?
Yeah, exactly.
And that's it. So we've simplified as far as possible because we've got a prime number there. 4 is nothing to do with 3, so, and a letter on its own. Okay. And I'll let you do the other ones. That means next week. Whoa. There's quite a few more. I'll pick another hard one here so that you don't find. That's why it says at the top, make sure you factorize fast. So let's pick a difficult one here. So I'm going to pick P. So here I've got 5, 10, and 15. First thing first, I'm going to get 5 out because it's a common multiple, right? P plus 2Q.
15PQ.
Yeah?
Yep.
I factorize the numerator. And the denominator, I'm just going to leave it the way it is because it's just a factor 15 PQ.
Start with whole numbers, possibly.
So 5 divided by 5.
3. 3.
And 15.
1/5.
Yeah, 3.
Yeah, 1/3.
And here, there's nothing I can do because P plus 2Q, just, you can't factorize it. It just stays as P plus 2Q. And the bottom is just 3PQ. So that's factorized fully, basically. There's nothing we can do with this. We just factorize it to its full. I've got P plus 2Q. Remember, because we got a plus here, you can't simplify anything there. If it was a minus, you can't simplify. It's only if we had a time, then we could have decided to simplify it. Okay?
Yep.
Yep, I see that.
So there's quite a few here. The other side are probably very much the easy ones. It's a bit like the example we did in what goes in the box. And here you've got to factorize to get your way out. And remember, you factorize not only the denominator, but sometimes you factorize both numerators and denominators. And that will conclude today's lesson. I think this, yeah, it's a long homework, this one, for this question, but there's only 2 of them, I think.
It's 2, 3, and 4.
3.
Squares.
I'm just gonna stop recording. And that should be us for today.